Hello everyone, welcome to the channel. So in this video, I'm gonna show you how to create a land use land cover map using Landsat 8 data in ArcGIS Pro. So now let's get started. So to create a land use land cover map, first we have to download our Landsat 8 data. So now open a browser. In that, click enter as a USGS Earth Explorer. So I have entered as USGS Earth Explorer. Now click enter to search and click the first result called USGS Earth Explorer. And now this is an official website, that is our USGS Earth Explorer, where we can download our Landsat 8 data. And the link will be given in the description to how to download a Landsat 8 data from this website called USGS Earth Explorer. And now let me get back to our ArcGIS Pro. So once you have downloaded your Landsat 8 data, so we're gonna insert our Landsat 8 data. So for that, we're gonna move on to this option called View. So in that, we're gonna click this option called Catalog Pan. So once you did that, so we're gonna navigate to our folder location here. So we're gonna click this option called Folders. So now we can able to visualize here. Have added my folder location called Landsat 8. So to add a folder location of your Landsat 8 data, so where you have downloaded your Landsat 8 data, so for that you're going to right click and click this option called folder connection and navigate to your Landsat 8 data folder location. So from here, once you've done that, so the folder will be visible here in the folder section. So you can click this arrow here. So once you did that, you can view all the different bands available in our Landsat 8 data. And now let me show you in my file manager. So now here you can able to visualize this is our Landsat 8 data we have downloaded from our USGS Earth Explorer. So to extract this data, we have to right click and you have to click this option called extract here. So once you click this option, all the different bands will be available here. So after that, we're gonna add our bands to our table of contents here. So for that, we're gonna click these options band. We're gonna select band 1 to band 6. And before that, let me explain about the different bands that is available in Landsat 8 data. So now we can able to visualize this is our Landsat 8 data here. That is our different bands that have been available here. A total of around band 1 to 11. So there is around 11 bands available here, and the description about the bands and the wavelength and the resolution here. So we're gonna select band 1 to band 6 and we're gonna composite the band 1 to band 6. So it is of 30 meter resolution. And here you can able to visualize here the band 8, it is of panchromatic band of 15 meter resolution, and band 10 and band 11 is of thermal infrared band of 100 meter resolution. So now we're gonna select band 1 to band 6. So now let me get back to our ArcGIS Pro. So here you can able to visualize band 1, 2, 3, 4, 5 and 6. So we're gonna select this band and add to our map. So for that, we're gonna hold the control key in our keyboard and select band 1 to band 6. And now right click and click this option called add to current map. So once you did that, we're gonna visualize all the 6 bands that is available in the table of contents section here. So now we're gonna band composite. So before that, we're gonna arrange this band in the order from 1 to 6. And now we can able to visualize if I arrange the band from 1, 2, 3, 4, 5 and 6. So now we're gonna select this band. So similar, we're gonna hold the control key and select the bands here. So once you did that, we're gonna composite our bands. We're gonna band composite. So for that, we're gonna navigate to this option called imagery. So in that, we're gonna select this option called process and click this option called composite. So it combines multiple datasets into a one multi-band raster. And now we have our image here that is available. So now we're gonna remove these bands here. We're gonna remove these bands. Right click and click this option called remove. And now we can able to visualize our composite image here. So to make some band combinations, you can right click this image. That is our layer called composite and navigate to this option called symbology. So currently it is in false color composite. So it is in the order from 5, 4 and 3. It is false color composite. Now let me explain about the different band combinations. So now you can able to visualize here. So this is a combination natural for natural color. So to visualize in true color composite, we have to arrange the band in the order 4, 3 and 2. So similarly, so to view the image in color infrared, we have to arrange the band in the order from 5, 4 and 3. So likewise, there is many combinations available here. You can check out the different combinations here. For agriculture, you can arrange in the order from 6, 5 and 2. So we're going to focus mainly on this particular that is our color infrared. So now let me get back to our Arc Pro. And now currently we are in false color composite, which is in the order from 5, 4 and 3. So now let me change to a true color composite, that is our natural color composite. So for that, we're going to select band 4 and band 3, and we're going to select band 2. So this is our natural color composite here. So similarly, you can try a variety of different combinations here. So now let me navigate to come back to our false color composite. So for that, we're going to select band 5 and band 4 and band 3. So this is the false color composite. So now once you did that, we're going to add a base map to our arc view, that is our map view here. So for that, we're going to navigate to this option called map. So in that, we're going to add our base map here. So we're going to add a imagery hybrid. So click this option called imagery hybrid. So once you did that, the base map is going to add it here. Yeah. So we have our base map in the background here. Let me close this. And now we can able to visualize that. So here there is a different features that are available within this satellite image. You can able to visualize that. So you can able to observe here the water bodies are highlighted in this color, blue color, and here you can able to visualize here that is our agricultural areas. So agricultural areas are indicated in red color. So you can able to view that, and the settlements being observed in this white color. So you can see that. So you can view the settlements here. So check this feature. We're gonna turn this composite image off. So now we can able to visualize here. So this is the settlement, and these are the agricultural areas. Now let me turn on our composite image. And now next we're gonna navigate to other locations here. So here you can able to observe this is a barren land, so which is indicated in this color, in a yellowish color. And to view that, we're gonna turn off this, so you can able to visualize here. So it is a barren land here. And let me turn this layer composite image on. And similarly, we're gonna visualize this set of colors here. So this set of colors you can able to visualize here. Thus you can observe the settlements here. So to view this set of color in green color, we're gonna turn off this layer. So you can able to observe here. So there is a fallow land as well as agricultural lands. And we are moving on to towards northwest direction. You can visualize a lake here, which is connected to another lake, and the name of the river is Krishna here. You can able to see that. And you can also visualize here the vegetation itself has a different level of shades here. So we are in color infrared, so we are using NIR. So in that, vegetations will be highlighted more. So the healthy vegetation will be highlighted, so more red color. So and also the different shades you can able to observe here. This part of the region has a agricultural areas, and similarly towards this part of the area, so where there is a forest land here, so you can observe the color difference between agricultural areas and this particular area here. So this is a forest land here. So from the satellite image, we have identified a water body and a dense vegetation and a normal vegetation, a barren land and a fallow land, and settlements. So using this set of feature classes, we're gonna perform our land use land cover mapping. So here you can able to visualize I've added my study area boundary into our table of contents section here. So now let me show you that. So here you can able to visualize this is my study area boundary. So now let me turn this on. So now using my study area boundary, I'm gonna clip the portion of this raster image. So for that, we're going to navigate to this option called analysis. In that, we're going to click this option called tools. So in the search section here, we're going to enter as clip. So once you entered as clip here, you can able to visualize the different tool that is available. So we're going to click this particular tool called clip raster. That is the data management tool. So we're going to click this. So once you did that, the tools opens here. So here we're going to input our raster, that is our composite. So that is our satellite image here, the composite image. And we're going to insert our output extent file here, that is our study area boundary. And we're going to turn this on, use the input feature for clipping geometry and maintain clipping extent. And you can choose your output file location here. And now click save. And make sure that you give a file extension as .tif, that is stiff. So once you did that, we're going to click this option called run. So here you can able to visualize our clip raster has been completed here. So let me show you that. We're going to turn this off. So here you can able to visualize our the clip raster of our study area from our Landsat satellite image. And now let us visualize the band combination in this layer. So right click and go to this option called symbology. So in that you can able to visualize, let us arrange according to the false color composite. So let me select band 5 and band 4 and band 3. And now I selected that. So there is a false color composite. And now let me minimize it here. And now I'm going to turn this base map here, turn on this base map. So and now to create a LULC map, we have to navigate to this option called imagery. So in that, we're going to select our classification tool. So make sure that you select your layer here. Once you selected layer here, the two tools will be visible here. So I'm going to click this classification tools. So in that, we're going to select this training samples manager. So it creates and manages training samples for supervised classification. So we're going to perform a supervised classification. So for now, let me click this option called training sample manager. So once you did that, a window pops up saying image classification. So in that, we can able to observe a predefined set of classes are available here. So that is, in case you want to give a training samples of water, you can just select this water class and you can so once you select it, you can just start drawing your to digitize the water areas. For training sample manager, you can start digitizing over that. And similarly for developed, barren, forest and wetland. And suppose if you want to create your own schema, for example here, you can able to visualize here. You can create a new schema, starting creating a brand new classification schema. So you can also create a new schema using this option, create a new schema. So now to digitize water, so I'm going to stick to this particular schema, that is water. I'm going to select this. So we can choose this option here. There are many options available. So you can draw a rectangle over the specified water bodies or any feature classes within the satellite image, or you can use a polygon tool. So you can digitize over that particular feature, for example water body. You can also use circles, and also the freehand option is also available. For now I'm going to select this option, polygon. So let's start digitizing. So we're going to navigate to the water body here. Now let's start digitizing our water body feature here. So once you digitize it, double click to complete the particular polygon here. And now let me give samples here. Double click to complete the polygon. So likewise, wherever you can able to see the water body's location, you start digitize those water body. So give for the training sample. So to provide more samples to water bodies. So likewise, let us give some samples for the river networks here. So you can able to visualize a river here. So we can give some training samples also for this particular river here. So basically what you're doing is we are just providing samples. So for classify that this particular set of value, the samples belongs to a water body. And now I have covered most part of the area for water bodies. So once you are given a set of water samples here, so you can able to visualize. I've given many samples, so you get a more accurate result. So next we're gonna select developed. So developed here indicates the settlements. So for example, this portion of the study region you can able to visualize that is in white color, so which will indicate the settlements. So now let me show you that. We're gonna turn this, okay, turn this off. So here you can able to visualize the settlements. You can clearly able to visualize the settlements here. So now let me turn on my composite. So basically the white color here represents the settlements, that is our developed. So you can able to observe here. Let me go to this part of the study region, so you can able to observe the settlements here. Let me turn this off, so you can able to visualize now. So now we can able to visualize it is a settlement. So for settlement we're gonna use the developed schema here. We have selected developed. Let me turn on this. So now let's start providing samples to our developed section here. So let me digitize this portion of this area. So now I have digitized few locations. So I've provided my training samples to my manager. So let me go back to other areas of this particular study region. So you can able to visualize this is our developed. So you're gonna select this. Basically developed indicates the build-up areas. So now let me select this particular area here. So it also indicates settlement. So to confirm your different features in the satellite image can be confirmed using our base map. So we can just add your base map into our ArcGIS Pro, and you can just view the details of the different features using our base map. And now have provided enough samples for our developed to our training sample manager. So here you can able to visualize it. So now was to group your training samples together. So we're gonna select this particular sample called water. So we're gonna select this part top one, and we're gonna hold our shift key, and we're gonna drag to up to the water sample, and we're gonna click this option called collapse. So it's gonna group our training samples together. So once you did that, so we can observe here the training samples get grouped together. And similarly we're going to select our developed sample. So we're going to hold our shift key, and we're going to drag down, and then we're going to click this option called collapse. Make sure that you don't collapse with water. So now click this option called collapse. So now we have our collapsed both the two samples, that is the water and developed. So next we're gonna select the barren here. We're gonna select it barren. So we're gonna draw the barren. We're gonna digitize the barren land here. So we're gonna take the training sample from here. Let me select here. So you can also visualize it using our base map here. So it is barren here. So now let me take some samples, training samples from this barren land. So now I'm taking samples of the barren land, and suppose if you want to delete one particular samples, so suppose you want to delete this particular sample here, so all you have to do is you have to select that particular sample and click this option called delete to delete the training samples. So while preparing our LULC map, it is very essential that you should have a field experience of this particular study region. So to basically to identify the different classes that is available in this particular study region. So each of the study region has its own different set of classes. So for that, a field visit could be an excellent to classify the LULC maps. So for preparing our LULC maps. So now we can able to visualize here. So it is a barren land here. And now I have taken enough samples for our barren land. So for that, now I'm gonna merge all this together. So we're gonna hold our shift key and we're gonna hold our control key and we're gonna drag down. And once you selected all the barrens, so you can merge using this option called collapse. And now here you can able to observe here the shrubland. Suppose you don't want this particular class, you can just right click and you can click this option called remove class and click yes to remove. And suppose you want to change the name of this particular class, you can just right click and click this option called edit properties. In that you can just rename the class here and you can choose your desired set of colors. So the next set of training samples is we're gonna select the forest and we're gonna digitize forest classes. So let me navigate to those forest areas. And now I have navigated to a forest area that is here. So now let me show you that. So this particular area, so I'm gonna digitize this, we're gonna take the samples of this particular area here. And comparatively, the forest area in this particular study region is less compared to the cultivated or agricultural areas. The forest area is very less compared to the agricultural areas distributed widely in the study region. So once you're given enough samples for our forest class, so we're gonna hold our control key and similarly we can select all the forest classes and we're gonna merge it. Now click this option. So we have merged our forest class. So next we're gonna select this particular class called planted or cultivated lands. Basically it indicates our agricultural areas. So for example, you can able to visualize this particular set of features here. So it is completely even agricultural areas. So we're gonna take the samples from this particular area here. We take samples. So likewise, you're going to take as many samples as possible, so to get more accurate results. So this is also a cultivated land. So let me take some samples here. So once you taken a good amount of samples for our planted and cultivated class, so we can shift to another set of classes here. So now let me merge this together. So merge this. So next we're gonna remove this particular class here. And now we're gonna rename this class to fallow land. Right click and click this option called edit properties. So in that we're gonna rename as fallow land. So once you've entered as fallow land, click OK. So now the new class called fallow land has been added here. So here you can able to observe here this portion of the study region. Now let me turn this off. It is a fallow land. So even the fallow land can be classified into many different types. Let me show you that. So here you can able to visualize here there's some common types of fallow land in LULC classification. So fallow land, the ideal cultivated land. This category includes land that is intentionally left uncultivated for a specific period to restore the fertility and the moisture content. The farmers may rotate the crop or allow the land to rest between the growing seasons. So this set of fallow land, that is abandoned agricultural land, the land that was previously under cultivation but has been left uncultivated for an extended period of time, either due to the economic reason or land degradation or other factors. So next is the shifting cultivation. This type of fallow land is associated with a shifting or slash burn agriculture, where the plot of the land is cultivated for the few years and then left fallow to a generator to regenerate, while the cultivation left shift to a new area. And grazing land is refers to the agricultural land that is temporarily used for grazing animals, allowing the land to recover from cultivation. This may be planned part of the crop rotation system. And here the green fallow, land left uncultivated but covered with a green vegetation, which can be intentionally managed to improve the soil health and prevent the erosion. And brown fallow, the land left uncultivated without any vegetation cover. This type of fallow land may be left barren for various reasons, including economic factors or the environmental conditions. So now let me get back to our ArcGIS. So this is a set of fallow land here. You can let me turn on this area. So in this set of period, it is a fallow land here. So now we're going to take a samples from this particular area here. So make sure that you select fallow and click this option here. Once you did that, we can just take the samples from this particular feature here. So once you took the enough training samples for the fallow land, so you can just merge the fallow lands together. So let me go back here. We can perform similar set of options here. Hold the control key. We're going to drag all this together and we're going to merge this together. So click this option. Make sure that you don't merge with other training samples. So we have merged our fallow land together. That is our fallow training samples. So now we need to save our training samples. So here you can able to visualize here. So now to train your that is to save your training samples, you have to click this option, save. So once you did that, you can navigate to your folder location to save your training samples. And now I have navigated to my training folder location, and I'm going to click this open, and you have to enter the name, and now click save. So once you have saved your training samples, you can navigate to this option here. So we're going to click this option called classification tools. So in that, we're going to click this option called classify. We categorize the pixels into classes, and here we're going to select this option. So once you did that, window pops up saying image classification. So in the first option here, there is an option called classifier. So in that, there is many options available. So there is starting from iOS, ISO cluster classification, maximum likelihood classification, random tree, and support vector machine. And there is a variety of different classification methods available. So now let's take this method, support vector machine. So it performs the support vector machine classification, which is the map your input data vectors into a higher dimensional feature space to optimally separate the data into different classes. So support vector machine can handle very large images, and it is less susceptible to noise and correlated bands or unbalanced number of sizes of training sites within each classes. So now we're going to select this method here, and now we're going to insert our training samples. So you have to navigate to your folder location where you have saved your training samples. So now let me navigate to my folder location. And now you can able to visualize we have our LULC training sample here. So suppose in case if you navigate your folder location and couldn't find the data here, so in that case you can right click, and so in that case if you couldn't find your shapefile, that is a LULC training shapefile, so just you can have to press this option here, refresh. So once you did that, your files will be available. You can just click and click OK. So now I have inserted my training samples here. Now next is the maximum number of samples per classes. So higher the number of maximum number of samples, it takes a longer the time. So for now we're gonna stick to 100. We're we're gonna take 100 samples per class. So after that, we're gonna navigate. So that is the output classified dataset. Choose the output location for this classified image. So you have to select this folder and navigate to your folder location of your choice to save this particular classified image. And now we're gonna save in this folder location here and click open. And now we're gonna save as classified image. And now have entered as classified image SVM, that is support vector mission.tif, and click save. So once you did that, we're going to click this option called run to run this classification. And now here you can able to visualize the support vector mission classification method has run. So this is our result, and this is our classified image. So you can clearly able to visualize here. So now let us make some changes to this color. So for water, we can make some changes here. Let me select this particular color here. And for develop, we're going to select the red color. And for barren, we can select, let us select a light orange color here. So it's okay. And for forest, we're going to select some dark green color. And now we're going to select for fallow land. So for fallow land, we can select a brown color. Let us select some light brown color. And let me select this one. And now leave it to a default color for fallow. So this is our LULC map. So you can able to clearly able to visualize here. So this is a settlement area. You can clearly able to visualize. Let me turn this off, and let me turn this off too. So here you can able to visualize. This is our settlements. Let me turn this on. And similarly, you can able to visualize the settlements are being clearly highlighted in red color. And for example, this particular is a river network here, just clearly highlighted in blue color. Let me turn this off here, so you can able to visualize the river meandering here. And similarly, let me navigate to other set of water bodies here. So this is our lake here. You can able to visualize. And let me turn this off, so you can now able to visualize it. And similarly, the forest area here, so it is highlighted here. And now the cultivation areas, so we can able to visualize the yellow color here represents the cultivated areas. Let me turn this off here. This is the cultivated areas, and similar to a particular composite image, this is a classified image. So in this way, you can able to prepare a land use land cover map, and you can add more samples to our training sample manager to get more accurate result. So it is good. So once we have completed our LULC classification. So next we have to move on to classify the area of each of these classes. So we're gonna classify the area. We're gonna find the area of each of these classes from starting from water, developed, barren, forest, planted, and fallow lands. So to calculate the area of this particular 6 classes, first we have to convert it to a polygon. So currently it is in raster file format. So now we have to convert it to a polygon, that is in vector file format. And now let us check the attribute table of this classified image. Right click and select this option called attribute table. So here you can able to visualize the different classes starting from water, developed, and barren, forest, planted, and fallow land. So now we can classify it, we can find the area. Once it we convert it to a raster to a polygon, and dissolve all polygons together, and we can find the area of each classes. And now let me close this, and now move on to this option called analysis. So click this option called tools. So we're gonna select this option called toolboxes. So in that, we're gonna navigate to a conversion tools. So here you can able to visualize this is the conversion tools. So in that, we're gonna select from raster to polygon. We're gonna select this tool, and now this is our tool, raster to polygon, and our input raster will be our classified image SVM, that is a support vector mission, and the field values will be our let's check that field values here. So we're going to right click and click attribute table. The field value is going to be our class name, so make sure that you select class name. So you're going to select this. I'm going to select class name, and now choose the output file location here. So now let me select my output file location. So in the shapefiles, I'm going to save my raster to poly LULC, and now I have entered a ras poly, that is raster to polygon LULC. Now click save. So once you did that, we're gonna click this option called run. So now here you can able to visualize we have converted to raster to polygon. So this is a raster to polygon converted file here. And now let me turn this off and let us visualize it. Right click and go to the attribute table. So here each of the polygons are classified. So there is a number of different polygons. So now we have to dissolve this together. We dissolve together. That is, we're going to dissolve all this developed together and forest together and barren separately. So for that, we're going to use our dissolve tool. And now to dissolve it, we're going to go to this geoprocessing tools here. So we're going to enter as dissolve. And now here you can able to visualize here. So now we're going to click this tool called dissolve data management tools. So once you did that, we're going to insert our input feature, that is our ras poly LULC, that raster to polygon LULC, and we have to choose, now we have to choose the output file location. And now let me select my output file location, and now I have entered as dissolve LULC and click save. And we're gonna dissolve the fields. The field we're gonna dissolve is the grid code and the class name. So once you have selected your fields, that is our grid code and class name, now we're going to click this option called run. And now the dissolve is completed here. So you can able to visualize here the dissolve LULC. So right click and go to the attribute tables here. So now you can able to visualize here the grid codes and class names are dissolved together. Now let me close this. So once you did that, we have to navigate to this layer. So we're going to make sure that it is currently in projected coordinate system. So for that, we're going to check that. So right click on this layer and go to the properties. So in that, we're going to navigate to this option called source here. So in spatial reference, so you can able to visualize the projected coordinate system is currently is WGS 1984 UTM zone 43 north, and the linear units are in meter. So now we can convert, we can calculate the area. So click OK. So it is currently in projected coordinate system. So click OK. And in case if you find your layer in geographic coordinate system, just you can right click and you can click this option here. You can click this option called export features. So here you can go to the environment section here, and you can choose the output coordinate reference system using this option here. So once you select it, you can just click OK to convert it to a projected coordinate system. So let me close this. And now let me open the attribute table again. Now to calculate an area, we have to add a new field called area. So for that, we're going to click this option called add. So once you did that, so we're gonna add a name here in the field name. So let me enter as area. So now I have entered as area in square kilometers. Let me remove this. So we entered as area square kilometers and select the data type. So we're going to calculate the area here. So I'm going to select double. And once you did that, we're going to navigate to this option called save. And now a new field will be created here. So you can just click here. We close this. And now you can able to visualize the new field is created, area square kilometers. Now to calculate area, you have to just right click this field and click this option called calculate geometry. So in that, so now in the property section, we're gonna click, we're gonna select the property as area. And now we're gonna select the area units. So we're gonna select square kilometers. So you can also select your choice of your area units. So now we're gonna select to square kilometers. And you can choose the output coordinate system here. So let me select the current map here. So it is in WGS 1984 UTM zone 43 north. And now click OK. So now it's going to calculate our area of each of this classes here. And now here you can able to visualize here. We have calculated the area in square kilometers. So now here you can able to visualize here the water, the total area and the total water in this study region, that is in areas. It is around 136.83 square kilometers. And for developed, the total area is around 1188 square kilometers. And for barren, it is around 1498 square kilometers. Forest is around 2606 square kilometers. Planted or cultivated is around 1379 square kilometers, and fallow land is around 974 square kilometers. And now let me close this, and now let me save this. So like this, you can just prepare your land use land cover map and calculate area of your study region. So in this video, I have shown you how to create a land use land cover map and calculate the area of each of the class using Landsat 8 data in ArcGIS Pro. So thanks for watching, and please subscribe to our channel and give us a like.